Okay, so there's a trick to classifying conic equations and or conic section equations, and it's to look at what's in front of the x squared and what's in front of the y squared, which we say is a and c. The other parts, if there's an xy, it gets b. A lot of times that's 0. And we have, 1x, 1y, we have a constant, and we label them all with these letters, but a and c are the big ones. And we think about this, a is equal to c, okay? In other words, when we go to divide, we're going to say, whether I divide by a or whether I divide by c, it won't matter. There's nothing on the bottom. And as you think about the equation for a circle, that's exactly what we would expect. We'd expect nothing on the bottom. We would just expect, we might say, x minus h squared, y minus k squared is equal to r squared. But we'd expect that from a circle. There's nothing on the bottom because they're both the same. A and c are the same. Okay, so that makes sense, hopefully. And then let's see, for a parabola, one of these guys has to go away because you can't have them both squared. So one of them needs to be 0. And if one of them is 0, then AC is also 0. Because you realize y equals x squared. They can't, you preserve the y term and you preserve the x squared, but C has to be 0 there, okay? How about when AC is greater than 0? Well, that means that they're both these guys are positive, okay? And if they're both positive, then I have the situation x plus y squared equals 1, or something like that. And if it's not 1, of course, I divide both sides, If it were 4, I'd say, I'll divide both sides by 4. Well, okay, but then there'd be something up here. You know what I mean. So this would be the ellipse where they're both positive because I'm adding. All right. What happens when they're negative? When AC multiplied together, that means one of these guys is negative, and I'm going to get something like this, over a squared, and x, something like this. For my ellipse, for my hyperbola. If it was this, that'd be an ellipse, but it's not. It's subtracting, so it's a hyperbola. Okay, so we can find these all out just by looking at A and C. So when we come down here, we say, A is 4, and there is no y squared. So you know what this means? This is a circle, right? Because one of them went away. Oh, sorry, it's not a circle. It's a parabola. It's a parabola. One of them went away and it left the other one squared, okay? So, yes, in this case I'm going to have y equals something. I don't know exactly what I'd have, but I'd have this situation. The x squared gets to be squared, but the y doesn't get to be squared, so parabola, yes. I don't know why I said circle. Go back up on the list. Parabola is when one of them is not there, okay? When they're equal, that's a circle. All right. So we look over here and we say, they're both here, and one of them is negative. So, okay, that means that AC together is less than 0 because it's negative. A times C is, so this is a hyperbola. And now that I don't trust myself, I look down and it's a hyperbola. Yay. Okay, so I look over here and I say 2, and okay, so they're both positive. Well, if they're both positive, what does that mean? AC is greater than 0. They're not equal to 0. They're not equal to each other. So we are at an ellipse. Okay. All right. And I look down here, and yes, it's an ellipse. Okay. Now we get this other case where they're equal. All right. Well, if they're equal, then that means it's a circle. A is equal to C, and that's a circle. And you can see these examples, but this is what's going on. So we're going to look down here and we're going to say, classify the graph of the equation as a circle, a parabola, an ellipse, or a hyperbola. So I look over here and I say 9 and 4, they're both there, and AC is greater than 0. So I would say that this must be an ellipse. All right. They're not negative, that'd be a hyperbola. They're not equal, that's a circle. They're not the same. Did I say that right? I don't think I said it. If they're the same, that's a circle. If one of them is 0, that's a parabola. Still struggling. Okay. So anyway, now we're going to graph it. We're going to sketch that. And we expect an ellipse. So let's see. If I factor out the 9 from x squared, I still have a 2x inside, and I sure would like a plus 1 if I complete the square. And I'm going to remind myself that I have plus 9 that I just added. Even though it looks like a 1, of course I have the 9 out front. And then I have plus 4 in front of y squared. I factor out the 4 from 16, I get 4y. And I'm going to say that half of 4 squared is 2, so I'm going to just put the 4 in there. And I'm going to add 16, because I just added 16 over here. In addition, I'm also going to add 119 over here. So 119 plus 25, that doesn't seem very nice. Anyway, in the meantime, I have x minus 1, because that minus right there, x minus 1 squared, plus 4 times y plus 2 squared. And make sure I did this right. I added a 1, I added a 9, I added a 16, that's 25. Okay, and so I'm going to have 144. Oh, that's not so strange at all. I don't know why I thought it was. But anyway, there we go, 144. And so that's nice. Good news. I thought it was something else. I divide everything by 144. And let's see what's left over. 144, I should be able to do this in my head. But for some reason, it's got to be 16, right? X minus 1 squared over 16, or 4 squared, plus the 4 comes out, and what's left? I think I was going to say 72, but that's not right. It must be 36. So 6 squared. I'm going to check my work just to make sure. And I'm equal to 1. So let me check real quick. 144 divided by 9 is indeed 16. And 144 divided by 4 is 36. Okay. So there's my ellipse. And I can tell that my center is at 1, -2. And then I'll graph that, and I want to set that up. So my center is 1, -2, so we'll call it right there. I look at this and I see, what's the dominant one? Well, here's the dominant one. They're both positive for an ellipse, but y gets the bigger number, so this is a vertical ellipse, vertically oriented. And so we'll say, let me go ahead and plot the point. A is 6, so I'm down here at 2, so I'll go up here to 4. I guess that's about 4 right there. And then I'll drop down here 4 more. 4? Why did I say 4? Oh, 2 plus 4 is 6. That's why I said 4. And then I'm down here at 2, so now I'm dropping down to 8. Something like that. Maybe that's too far, but my best estimate. This is a -2. This is a +4. So my vertices are 1, 4. I don't know how I didn't get that. How didn't I get that right there? 1, 4. And also 1, -8. And let's see, my foci. This is an ellipse, so I'm going to say c squared is equal to a squared minus b squared. So that's 36 minus 16 is 20. So I think that's about 4.5. So we will say, we'll go from here, 4.5, we get about 4.5. Is that right? No, it's not. No, it's not. From negative 2 with 4.5, we get 2.5. And we also get 4.5 and negative 2, we get, we're subtracting, so we get negative 6.5. Alright, and I will plot those with this color here. We'll say that's 6.5 down there, negative 6.5. And we'll say about 2.5. I'm fudging a little there. Okay. And, well, I know B as well, so where's B? Let's see. B is 2 out, so I'll go over here. I need that space, unfortunately. And I need this space right here. Okay, so I will go ahead and graph that. I don't know what color I should use. I guess I'll use that. Too much of a football, but you get the idea. What else can I say here? Is that it? Yes, I think that's it. So, we're good.